So in my my previous video that I had, I think the segment was cut. So I want just to summarize for you refraction of light. That's the bending of light. So if you do have a ray of light that is coming in that direction, moving from air going into, glass. Remember what we said, it will find the normal at the boundary between air and glass. When you are moving from a less denser medium to a more denser medium, it bends away, it bends towards the normal. And this is what is going to happen to the ray there. It will bend towards the normal. That is what you can see there. Remember, that is the angle of incident, and here the angle there, that is the angle of refraction. And again, it moves from a more denser medium, it wants to go into a less denser medium, going back to air. So it simply means that it will move again, it is going to move away from the normal. So this is what you're going to have there. So now they can ask you what really is going to be happening, or what names can, are these rays called. Remember, this one is what we called as being the incident ray. That's what you need to remember. That is just representing the normal. That is the normal. That is the angle of incidence that we do have there. So that is the angle of incidence that we do have there. I is representing, angle of incidence. Then this one that we have here, this is the refracted. That is the refracted ray. And remember your small r there, that is representing the angle of refraction. So that is the angle of refraction. And this ray now that is coming out from the glass block, this is simply called as being the emergent. So we call it as being the emergent ray. And the angle between the normal and the emergent ray, that one there, that is called as being the angle of emergence. So that is what you need to remember. It is a summary of what we call as being refraction, of what we are calling as being light. So the way we have laws of reflection, we also have what we call as being laws of refraction. So there are two laws that you need to remember. Now, according to the first law of refraction that we can simply state, it is not complicated. We can simply say that the incident ray, refracted ray, and normal meet at one point and are in the same plane. So that is the first law that we can talk about. So the incident ray, refracted ray, and normal meet at one point are in the same plane. That is the first one. Then the next law is also called as being Snell's Snell's law. So that is called Snell's law. So in other words, what does Snell's law state? Well, it simply says that the ratio of so we can simply say the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. So it is actually a constant. That's what we mean. In this case, the constant is called the refractive index. That's what we call it. So according to Snell's law, it simply tells you, so we can write it in this case, that Snell's law tells us that the refractive index, in other words, the constant, the refractive index is equal to sine I divided by sine of the angle of refraction. So meaning if you have got two media, that you have maybe air and water there, and you know what the angle, you know, let me just write it, draw it properly. So if you know what the angle of incident is and you know what the angle of refraction is, you can actually calculate the refractive index of the second medium. So that is what it simply tells us. So the ratio of the sine of the angle of incident to the sine of the angle of refraction is a constant, but that constant is what we call as being the refractive index. And of course, you are finding if this is the first medium where light is traveling and that is the second medium where light is going, it simply means you are finding the refractive index of the second medium where light is actually traveling into. Let me just quickly try to illustrate it this way. Let me just try to, we can also, so this is the typical formula that you are going to be using. They are very important. Now I want to actually illustrate it this way. Let me just try to draw it properly so that you are able to see. All right. Let me say that this is medium 1, and let me say that this is medium 2 where light is traveling into. We know this is the angle of incident, we know this is the angle of refraction, and of course for each media, different media have got different refractive index. So let me say for medium 1, let me say that the refractive index is N1, and for medium 2, let me say that the refractive index is equal to N2. It simply means that we can write and simply say, if I multiply the refractive index of the first medium multiplied by sine of the angle of incident will be equal to the refractive index of the second medium, N2, multiplied by sine of the angle of refraction. So this can also be used in our discussion. Now of course when you work out that, you are going to see that we can actually see that n 2, I can simply say maybe n1 over n2 will be equal to, in this case, sine, okay, let me say that sine r in this case. So if you want, let me just start with n2 so that we mimic it, that n2 over n1 will be equal to sine I over, in this case, sine r. So this can actually be changed to that. As you are going to see later on, you'll be able to actually understand that. But you can use that, or you can actually use that. Now I want to give you some refractive index of some material that we do have. So I want to give you some refractive index of some material that we do have. So for example, let me say refractive index of common materials that you do have. So for some of them, you just need to know. For example, ice has a refractive index of about 1.31. We can talk about water, which has a refractive index of 1.33. We can talk about maybe ethanol. Ethanol has a refractive index of about 1.44, which may be similar to also paraffin. Yeah, similar to that. We can also have what we call as being maybe glycerin has a refractive index of 1.47. We also have what we call as being perspex. Yeah, usually this is glass, depending on the type of glass that you're dealing with. Perspex, let me just say perspex, it has a refractive index of 1.49. We can talk about maybe glass, maybe flint glass, about 1.52. You can also talk about diamond, which has a refractive index of 2.42. So the common one that you need to remember is water. You need to know the refractive index. You also need to know about maybe glass and also perspex. So you need to know these refractive index and also diamond. But not to be forgotten is that in a vacuum or in air, the refractive index is simply 1.00. So that is what you need to remember. I think these are some of the common refractive index that you may actually come across. Of course, in some books they may tell you that what we are calling as being maybe perspex may actually have about 1.50. It depends with what the question is telling you. In this case, glass, especially crown crown glass may actually have a refractive index of about 1.52. So it will depend, but anyway, these are approximate values that I've actually just given you. So different materials have got different refractive index. That is what I wanted you to get to appreciate about that. Okay. Another thing that we can talk about, that I can talk about, since we say that according to Snell's law, it tells us that the refractive index is the ratio of the sine of the angle of incidence to the sine of the angle of refraction. So meaning that, how can we actually use that one? How can we use this one to do some calculations? Of course, you can use it to do some calculations. Let's imagine that they have given us a diagram there, and they tell us to say that angle is equal to 30 degrees, and they tell us that that angle is equal to maybe 20 degrees, and this is air and this is glass. They'll simply tell you to say calculate. They'll tell you to say calculate the refractive index of glass, because light is traveling from air going into glass, so it simply means they want you to find the refractive index of glass. So how do you find that? Remember, what is important, the angle of incidence, do you know it? Yes, it is equal to 30 degrees. Identify the angle of refraction, which is equal to 20 degrees, and substitute in the formula. Refractive index is equal to sine I over sine R. So refractive index will be equal to sine I is 30 degrees divided by sine R, which is equal to 20 degrees. The common mistakes that pupils do, they'll just say 30 divided by 20. But remember, it is sine. You need to include that sine, not 30 divided by that. You need to include sine. The way I'm doing it, sine 30, in this case, divided by sine 20. And you can leave it to one decimal place. So that is simply going to be 1.46, and that is the refractive index. Remember, it's a ratio, meaning it has got no units whatsoever. So that is what you need to, remember. All right, let's do another one. Let's try to do another one there. How can you actually do it? Suppose I also give you a particular material. I give you a particular material, and I tell you that the angle there is simply 50 degrees, and I tell you to say that this angle of refraction is simply 40, let me say just 43 degrees, or let me say maybe just 42.8 degrees, and I tell you that this is water and that is perspex. And I tell you to say find the refractive index. So how do you go about that? Again, it's very simple. You just need to identify in this case. So we can simply say refractive index is sine I over sine R. So that's what we are going to have there. So in this case, it is going to be sine I, the angle of incidence is 50 degrees, divided by sine of 42.8 degrees. Then you can use your calculator to actually calculate that. So this is going to be sine 50 degrees divided in this case by sine 42.8 degrees, and what will that give you? It will give you 1.13. So that is what you're going to have there. Now I want you to take note. Sometimes we may give you a variety and we may tell you. So what we can simply do, I'll look at some more typical examination questions, then you'll be able to see them in my other videos. Here I'm just trying to illustrate to you so that you are able to see. So what we can do is that we can give you a whole range of angles that we can actually get to give you. For example, I can simply get to give you 20 degrees. I can simply get to give you 70 degrees, and maybe I can simply get to to actually give you an angle there which is slightly smaller in this case. So maybe we can say that you have got 40 degrees and that is 50 degrees there, and we can tell you to say find the refractive index. Yeah, find the refractive index of medium, let me say medium 2. Let me say this is medium 1, and let me say that is medium 2. So how can you go about that? So what is important? Just identify the angle of incidence. Those are important. If you notice from there, it is 70 degrees, and the angle of refraction, it is actually 40 degrees there. Then you apply it in your formula. It is sine I over sine R. So the refractive index would be sine 70 degrees over sine 40 degrees. So what would be the refractive index? We can again use a calculator. It is simply sine 70 divided by sine, in this case 40 degrees. What is that going to give us? It is going to give us 1.46, and that's the final answer that we are going to have. Now, this Snell's law that I was talking about, in most cases you are going to be looking at it, you are going to be carrying out an experiment, or it is going to be coming in your exam. So I can simply say that Snell's, let me say Snell's law graphically. Suppose they wanted to illustrate Snell's law graphically. How is that going to be? Well, it simply means that you are going to plot a graph of, in this case, of sine of the angle of incident and the values of sine of the angle of refraction. Now when you plot a graph of sine of the angle of incident and sine of the angle of refraction on the x-axis and this on the y-axis, you are going to have a straight line of best fit. Now if you get a straight line of best fit, if you were to find a gradient by taking 2 points, so that by taking 2 points along that one, the way we find the gradient, of course, the way we do that, so that is the change in the x value, in this case change in sine R, and there that is the change in the y value, that is change in sine of the angle of incident. You are going to find that the gradient, look at that, in this case the gradient of this line represented by m will be equal to the change in the y step divided by the change in the x step. So what is the change in the y step? The y, remember, is this one, and the change in the x step is this one. So it will be sine I divided in this case by sine R. So you can see the gradient is equal to sine I divided by sine R. But what is sine I divided by sine R? Well, this is actually equal to what we are calling as being the refractive index, n in this case. So remember the gradient of this line actually, so the gradient m of that line is representing what we call as being the refractive index. So in the exam they can tell you to plot values of sine I, sine R, and you'll be able to come up with, you need to draw a line of best fit, a straight line of best fit that you're going to have. And remember, the gradient will always represent the refractive index when you plot sine I against sine R. So that is what you need to remember. Please watch out for more as I talk about the refractive index involving the speed of light, or the relationship between refractive index and also the speed of light.